Hi friends, in this video I am going to show you a practical experiment which is derived from theoretical aspects of electromagnetic fields. What we are going to see is field, electrical field inside a equipotential surface which encloses a volume is equal to 0. How? We will see this practically. First we will see is basical theoretically, and we will go for mathematical expressions. First basic, second mathematical proof, third practical experiment. First basic. I am considering a volume, and on this surface I am given a which is equipotential. That is, if we consider the potential, here it is V, here it is V, here it is, everywhere it is V. And if we take delta V, that is potential difference, V2 minus V1, difference V1, V minus V, which comes out to be 0. That is, potential is 0. That means there is no field exists, because electric fields relates to voltage or potential difference, what we can say. Okay, next is mathematical proof. To know this, first we need to know about basic Laplacian equation, which you are familiar with. This del square V is equals to 0, and Gauss law, E dot ds is equals to flux for a charge free region. This is a charge, net flux entering is equal to net flux leaving. So E dot ds will be equals to 0. We will use this in our mathematical expression. Next, coming to us, del square V is equals to 0 can be written as, this can be written as, this is, I am expanding the above one, that is divergence of this one, which gives again del square V. This is written as gradient V square plus V times, we know that del square V is equals to 0, so this goes out, and integrating on both sides, over a volume dV, and by using divergence theorem we can convert this, as this is a divergence of volume integral, we can convert this term into surface integral by over ds is equals to, and this can, first we will keep this aside, and first we will take on left hand side. This is a V is a not integrated, we are not integrated this one, del V ds. We know that E is equals to minus del V, So substituting del v is equals to minus e, we get minus e dot ds, and from here e dot ds equals to 0, we are substituting here, that is 0. This is equals to right hand side, that is integral del v whole square dv, and we will get del v is equals to 0. From e is equals to minus del v, if we substitute 0, e equals to 0. That is, if we consider a equipotential surface volume upon which surface is equipotential, that is, if we ground one of the set center and high potential is v at everywhere, v potential difference will be is equals to v minus v, that is will be equal to 0. So there will be no charge. There is electric field generally produces from a charge, so there is no charge, no field will be inside the box, that is metallic box. We should consider only metallic box, which is so it can sustain equipotential. Now we will see it practically. What we are going to see it practically is, we will take a, you too can do this experiment in home. Now I am doing it by taking a tiffin box, that is metallic tiffin box, which is equipotential surface. Now I am taking two mobile phones. Generally mobile phones, if we call from one phone to another phone, the waves are electromagnetic waves, and depending on frequency, these are divided based on bandwidth, they are divided into some frequency for calls and some frequency for internet. Now I am showing you practically for calls. The rays are now we will come back. The rays are electromagnetic rays. Now I will take one mobile phone and I will keep it in a metal box where the metal box is equipotential, that is it has same potential on its surface, so the field inside will be is equals to 0. So there will be no electric field inside the box, no electric field inside box. So if I ring that mobile inside the box from outside another mobile, it will not ring, because the rays from outside will not travel inside, because that entirely is covered with a metal box, where there is no chance to no chance for what we can say that there will be no matching for that waves, that is the waves will not enter into the tiffin box. Okay, now we will see this. Now I am considering a metallic box. This is metallic box. This is a large box. You can take small box also. Don't feel think that it is very big. I am considering two mobile phones, Motorola Moto G. This is Nokia phone. Same number I am calling, 9160151681. Okay, I am getting ringing. Okay, now I will cut this call and keep the same phone inside the metallic box, and now I am closing the surface. Now if I call again the same number 9160151681, and if I am ringing that, it should not ring, because the field inside should be 0. So now I am ringing. I am on loudspeaker also. See, the call is going on. You can hear that sound. But the phone inside is not ringing. Okay.
చేయాలనుకున్న కస్టమర్ ప్రస్తుతం లభించటం లేదు. బీప్ అన్న శబ్దం తర్వాత మీ మెసేజ్ ని రికార్డ్ చేసి వెంటనే వారికి వాయిస్ మెసేజ్ పంపండి. సాధారణ ఛార్జీలు వర్తిస్తాయి. ఆన్లైన్ లోనే నిలిచి ఉండండి. The customer you are calling is not available. Leave a voice message right now.
Now I have transferred the mobile from inside this box to inside this box, and now I am bringing that again for your convenience and for checking. You can see that the phone is not ringing because the field inside this box, which is an equipotential surface, this is also a metallic box, this is an equipotential surface, so this is also zero. So the field inside is zero, so no electromagnetic waves from this phone to inside that phone will not enter. So we can check vice versa by keeping another folds also. This Motorola phone inside the box, and now we'll check you with vice versa, that is opposite one. See, now I am bringing that phone. The phone is not ringing because field here is inside is zero. Now I will check you the same phone and same you saw you see the number again same. I will keep it this and I will open the box, and now I will ring it. Okay, and we can also apply many theoretical aspects to practical aspects if we study it clearly. I have also learned the same thing from one of the lecturer from IIT Kanpur. So thank you. I will be back with many such experiments. Thank you. Okay, visit my blog. Thank you. Bye.